Amazing. Thank you guys so much. And thanks for coming out so early. I know it was a late night for most. My name's Irene, and I'm head of strategy at LayerZero Labs. I joined LayerZero Labs originally as an integrations engineer and previously was head of biz dev and integrations, now thinking more broadly about product roadmap and a lot of the upcoming endpoints that we're releasing. And so today I'll be going over these 4 broad topics, but I think the key area where I want to hone in on are the ideal principles behind cross-chain messaging protocol design, and also why omni-chain assets matter, and how you all as developers and founders should be thinking about omni-chain assets. Okay. We were having some issue with this before. So what is omni-chain interoperability? I'm sure you guys have all heard the phrase multi-chain, omni-chain, chain agnostic, cross-chain. What are the differences between all of these? The key idea with interoperability is sharing data and information between disparate networks. And so you hear analogies about different blockchains as being like different cities or different countries. But in reality, a more accurate analogy would be that different chains are like different planets. And so if $1 million is transacted on one chain, how do you actually know and can confirm in a trustless and decentralized way that this occurred on a different chain? Whereas when you say the blockchain, as some people do, it sounds as though there is an inherent network or connectivity across these disparate networks. So it's really important to understand that. Unified data and information sharing between disparate networks is the interoperability that we're aiming to achieve between different blockchains. And so why does this matter? Well, from a user experience perspective, right now we expect end users to care about the different chains they're interacting with, the different gas tokens that are required, and then also the different features and latencies involved. And from a developer experience, it's very, very difficult to weave together the strengths of ZK Sync and Avalanche, a subnet and a supernet, and Solana and Ethereum. Ethereum's where the liquidity is, but you want to leverage Solana for fast settlement. How do you then construct the most ideal user experience and abstract away the complexity of individual chains? And then also composability. You have a protocol on one chain. Does it have meaning on a different chain? And why is it that we're still building with the concept of tribalistic affinity for an individual ecosystem? And so at a broad scale, omni-chain interoperability matters a lot. And if we think 5 to 10 years out, if we expect there to be more than an additional 10,000 users, let's say 100 million, the experience has to be one that doesn't put the onus of education on the end user. And so what is LayerZero? LayerZero is the leading omni-chain interoperability protocol. And in actuality, it's a generic messaging primitive. LayerZero allows for arbitrary contract invocation, meaning you can communicate between smart contracts on different chains using the protocol. And so I had alluded to the broader concept of what interoperability means. I think another way to think about it is in the late 70s and early 80s, the internet was the intranet. It was a set of research institutions, Stanford, MIT, Harvard, universities in Europe as well, and there was no way to actually share packets of information. And so then there was the advent of TCP/IP, which continues to this day to be the underlying protocol that allows the internet to scale. We are at that point right now with blockchain application design. And so what is that holy grail problem? It's information sharing and asset transfer in a secure and decentralized way between disparate blockchains. That's our North Star at LayerZero. And so, as I alluded to before, you can abstract away the complexity of building multi-chain and actually design for the next 100 million users in Web3. I often say to my friends in the industry, if you are still so naive as to think that 5 years from now, people will care about the underlying chain and want to go to a centralized exchange and get 5 different gas tokens to transact in a way that touches 5 different chains, you probably don't call your mother very often, or you don't talk to your childhood best friend, or you forget that the best Web 2 applications you've used are optimized to reduce churn, right? Like how quickly can you go from starting in the application to actually accessing the value that you were promised when you began? We all know that onboarding in crypto is really difficult, but then what about once you've onboarded, you have your wallet and you want to lend on one chain and borrow on another? We're in the early innings of how you design that, and LayerZero is the infrastructure that developers can use to get there. So the core concept of LayerZero, as I said, is smart contract communication across chains. And the architecture of LayerZero is really unique. It's not a bridge, and it's also not a typical messaging protocol. This is the architecture. And at the end, if we have time for questions, I can pull back to this slide and go a lot deeper if you guys are interested in the different components. But what you see on the left-hand side is chain A, and then on the right-hand side is chain B. This could be Arbitrum and Optimism. It could be a SuperNet and Polygon POS. There's the user application and then the endpoint. And so endpoints are smart contract libraries that we have deployed on all of these different chains. And this is also the developer interface. So in your smart contract, when you call the function LZ send or LZ receive, it's interacting with this endpoint. And the endpoint ultimately is dealing with the state data. And those two off-chain, let's see if we can go back a slide. The two off-chain components, could you go one slide? Okay, let's see if we can figure this out. Okay, the two off-chain components you see there, Oracle Z, Relayer A. The way LayerZero works and breaks apart the state data is we have these two independent entities, but two is actually misleading. It could be an infinite number of independent entities, which we refer to as the oracles and the relayers. This is actually a misnomer because in the LayerZero network, all an oracle has to be is an entity that can retrieve and submit a block hash or a block header. And all a relayer needs to be is an entity that can retrieve and submit a transaction proof. They have these two independent tasks and can be selected from a marketplace of offerings of oracles and relayers. Your team could actually run one of those components yourself. So you play a role in securing your messaging, but you also don't have unilateral control. It keeps moving ahead. Ultimately, I don't know why this is happening. Ultimately, the state data is broken apart and recombined on the other side and sent to the endpoint on chain B. So then moving ahead, there are three design principles that we really revered in the design of LayerZero. And those three design principles are immutability, permissionlessness, and censorship resistance. And when we think about what a true protocol is, not a service, but a protocol, these are the three things you should be considering as developers. So we'll dive into the first one. What does it mean to be immutable? There are evergreen protocols like Uniswap that are a great example of this. All of their smart contracts are immutable. They're non-upgradable, and they are pushed in a way that involves so much care and conscientiousness and attention to security. The issue with mutability or upgradable smart contracts is that with every upgrade, you reset all security. So when we measure security for bridges and messaging protocols, we're thinking about value secured over a period of time. And if you look at all the major bridge hacks, in 2022, bridge hacks were the reason for the most loss of user funds. It was in the billions. Actually, nearly all of them were due to smart contract upgrades and bugs. It wasn't due to fundamental architectural flaws. This is true of the wormhole hack. This is true of the Nomad hack. And they were ultimately benign as well. These were developers who were trying to improve the functionality of their bridge, but by pushing several lines of code and not running a test in advance or perhaps getting it audited multiple times, there was a bug that introduced the vulnerability, which allowed for a major hack, and reset all security for all applications building on top of it. It's existential risk for your application if part of your infrastructure is built with upgradable smart contracts. And ultimately, it's not a true protocol either. And we think about this when we say service versus protocol. A service relies on the owner company to maintain the security of their underlying project. And it's also putting or requiring all of your trust in that developer company. Whereas a protocol can exist in perpetuity. The labs company, LayerZero Labs, for example, could, as a team of 42, get into an awful accident and entirely disappear, but all 6,000 smart contracts on mainnet can continue leveraging the protocol. They can switch out the off-chain infrastructure and don't need to necessarily communicate with LayerZero Labs to continue enabling cross-chain messaging. And then, as I said, even benign developers will make mistakes. There are SecOps or security operational decisions you guys can make that can allow for you to push immutable smart contracts or choose infrastructure that is truly immutable in a way that is secure. That means, every single piece of code, even if it's several lines, should be audited multiple times. At LayerZero, we always break apart into red and blue teams and conduct sort of attack mechanisms internally. We make sure we go through rigorous code review, and we also only ever deploy programmatically. So how can you strip away the risk of human error? This is a visual right here that shows what I was referring to in terms of resetting security. So on the left-hand side where you see the red body of area, that's all the lost security when you push another line of code. And then that blue strip is the upgrade to the smart contract. So it resets the perceived security. And an example of this is we're seeing some bridges saying we're exploring ZK technology now and we're doing this huge overhaul. It's so exciting. That actually means that all of that time of secured value is technically lost and reset. There could be one tiny error, and now you are buying into all of that risk. So what does that mean for ideal cross-chain messaging protocol design? When we were creating the protocol, we thought to ourselves, we want to create something that can actually evolve with research. Today, ZK technology is really interesting, but 5 to 10 years from now, who knows what the best validation techniques are? And in fact, I don't think it makes sense for the security practices we buy into today as the best security practices 10 years from now. And so our team was constructed largely of researchers, and we wanted to design something that could evolve. So those endpoints are libraries which exist forever, and users and developers can choose to point to them, but it also means that we can deploy new smart contract libraries. We can deploy one that leverages ZK. We can deploy one that leverages optimistic validation techniques. 10 years from now, it could be something else. In fact, LayerZero is open and permissionless, so one of you could deploy an endpoint as well, and developers can audit all of these smart contract libraries and decide for themselves. So it puts the security back in the hands of the developer. What you see right here is that with library upgrades, it doesn't reset the security lock. These are still immutable contracts, and it allows for the time and money secured to reach a threshold that is acceptable before developers choose to opt in. No forced upgrades. At no point can our team rug your protocol. And that's the way that cross-chain messaging protocol should be designed, in our opinion. So the second principle is permissionless. That means any developer can build with your protocol. It's permissionless deployment, and also permissionless participation in the validation or network. Any application team, it could be a college dropout, can run an Oracle or a Relayer. So they can own their security to whatever extent that they'd like, and also participate meaningfully in the eventual community and broader network of LayerZero. We believe that permissionless is the better way. And one example of this is we created something that was the Girly ETH bridge. And rather than sort of taking a political stance on whether or not there should be a market around testnet tokens, we thought, create something that gives developers options. And that is one example of permissionless deployment. And without immutability, without smart contracts that are guaranteed to not be changed or patched, permissionlessness is never guaranteed. So there was an example recently of a blue chip NFT project that migrated from Solana to Ethereum and Solana to Polygon. And there was a bug that was actually found by a white hat on Twitter, and shortly after, the developer company went in and quickly patched the upgrade. And you could perceive that as great, they moved really quick, but it actually revealed to everyone on crypto Twitter that the owners of those smart contracts at any point could rug all of the holders of that NFT because of the way they designed their smart contracts. And then finally, censorship resistance. This is one that is really important to me. I spent time in university before dropping out studying anti-surveillance technology, and I think it's particularly timely to think about because of a lot of the regulation that is forcing certain infrastructural technologies or even Ethereum validators to censor. If you design your technology in a way that allows you to censor, you will be forced to pervert your technology and use it in that way. And so if you design your protocol to not allow censorship, then you are buying that agency for developers for the rest of time. So validators cannot reorder the delivery of messages or censor individual messages in the way that we designed our cross-chain messaging protocol. That means that every message is nonce order enforced. At no point can we pull a message out, refuse to send it, reorder. And that also means that a high-frequency trading firm couldn't go in and try and extract extra value. Every other bridge in messaging protocol right now is not censorship resistant. And so in addition to this, applications can always choose different off-chain infrastructure, as I said. And once again, without immutability, censorship resistance is not guaranteed. A really important use case for this in the cross-chain context is cross-chain governance. So if you're using a messaging protocol to allow for your multi-chain protocol to have votes come in from different chains, but then settle and execute on Ethereum, if there is the possibility to move messages around or to refuse to send one, it's possible for votes, important votes, to be altered for malicious purposes, or not. But I think for many original developers in the space, this concept from divestment from institutional powers is incredibly important. So then, now we're getting to the omni-chain asset side. OFT and ONFT are shorthand for these two standards that our team created, omni-chain fungible token and omni-chain non-fungible token. These are ways to mint or convert single-chain assets into natively multi-chain assets. That means that they can move between chains without ever being wrapped, so locked in a wrapped token bridge, which is inherently a security risk you're now putting in the hands of end users. Because through a wrapped token bridge, you're locking the actual asset in the contract and minting a synthetic one, or an IOU, saying, if you ever cross back this bridge and you pay 5 to 10 bits, then you'll get the real thing. But if we get hacked and you don't cross back in time, you're left with a meaningless asset. It also means that you've created an asset that can transfer between chains without relying on a middle chain or external liquidity pools. It's the ultimate form of an extensible token. So if you are the team behind Trader Joe, for example, and you've decided to convert the Joe token into an OFT, which they did a few months ago, you own your contracts, you own your security, as I showed with the network, and you can also own your fees. If you wanted to, you could take a spread for every single transfer. And now your token has native and canonical meaning everywhere, or on the chains that you choose for it to be on. And what you see on the right-hand side are 3 examples of ONFTs. So there's Pudgy Penguins, which recently used LayerZero to go from just Ethereum to Arbitrum, BNB, and Polygon, and Kampai Pandas and Tiny Dinos. These are now some examples of OFTs. And I had mentioned Joe, but BTCB is an example that we're particularly excited about. Ava Labs, particularly Luigi, who's fantastic and really the visionary behind this, decided that they wanted to create a version of Wrap BTC that was incredibly easy for developers and retail users. And so they launched it as an OFT, and it very quickly expanded and is now one of the only forms of native Wrap BTC on more than five chains. And it actually really drove user adoption and doubled the supply. So this is a graph here that's showing where in time BTCB adopted the OFT standard and how that impacted its usage. You can see right here, after the conversion, supply growth doubled. And I actually, just walking around the conference, have run into so many protocols that have said, we're now adding support for BTCB and pools of it because it's so highly requested and is incredibly easy to use. And again, if you're launching a token and it's not canonical or native on multiple networks, it will be wrapped. And once a token is wrapped, you lose control over the pricing, you lose control over whether or not that underlying bridge gets hacked, but that reputation is yours. It's still tied to your underlying protocol in the same way that wormhole wrapped USDC, for example, is still strongly associated with Circle. And I'm going to end on this slide here, which is one that's showing the growth of applications that are being built in a cross-chain or chain-agnostic or omni-chain manner. On the left-hand side, you see cumulative contracts on testnet. Right now, we're trending towards, or I think now we've actually surpassed 30,000 contracts. And on the right-hand side, nearly 6,000 on mainnet. And so this year will be huge, particularly for gaming. We're seeing so many projects that are finally going live and will showcase use cases where all of their in-game assets are ONFTs. So, for example, your avatar in an Avalanche subnet can now be moved to the sandbox on Polygon and can be unwrapped, maintain provenance, have the value that it has in the subnet, but can now be your avatar at a Travis Scott concert. Or you can move your in-game rewards to Ethereum and sell in a marketplace that has better liquidity. Now your in-game currency can have utility in different networks. It can move from subnet to C-chain, subnet to mainnet, to ZK Sync, to Arbitrum. From the consumer fintech angle, we're seeing cross-chain swaps become so much easier and more efficient. From the DeFi side, I alluded to a simple example, lend on one chain, borrow on another. There are so many other interesting things that we're seeing, but OFT is really leading the charge there. And on the NFT side, hats off to the NFTs and culture team at Ava Labs and Ave Sans. We're seeing projects in fine art curators think about how you can future-proof your assets. If you think back to a year ago in the Terra Luna collapse, we had these fantastic communities and really high-value NFTs be entirely siloed after this underlying network that was perceived to be evergreen and secure just obliterate in front of our eyes. And earlier this fall, we also saw some other communities and networks really sort of hit a low point because of instances that were out of their control. And so if you're thinking about an NFT like a Rothko that you can have in your Miami apartment, but you can also ship to London and put there, you have this asset that is yours. You should be able to move it wherever you'd like and appreciate it wherever you are. A digital asset should also be boundless in that way. And you can extend that analogy to thinking about 5-cent NFTs, sure. You can extend that analogy to thinking about car ownership, utility-based NFTs, whatever it is. There's no reason why it should be fragmented across different networks. So I'm going to end there. I wanted to make it really casual since it's a smaller crowd, and I'm happy to answer questions. But thanks for coming out and listening. We can do questions.
Hey, thanks for the talk. It was very nice to hear about the inner details, especially the architecture slide. So I had a question about the validators. So I think you mentioned that they maintain the sequence in which the messages go from one chain to the other. So what would happen if, let's say, one of the messages in this queue does not get delivered, is dropped, or there's just not like the right performance on one of the chains to receive? Do the other messages in the queue then take the toll as well?
So message delivery through the LayerZero network is forced in sequential order. And so because of that, if, for example, in a cross-chain governance context, the protocol wanted to halt messages, it would stop that entire pathway for that period of time. And another thing to keep in mind that I didn't get to touch on was this concept of instant guaranteed finality. And so Stargate, which is the DeFi protocol that we launched as a proof of concept alongside LayerZero about a year ago, demonstrates this. This means that if you begin a transaction on your source chain and it's priced for the destination chain, you are guaranteed to get exactly what you've been told on the destination chain. There is no alteration there, and the LayerZero relayer in particular will eat the cost should there be a change.
Okay, thanks.
I think we have two right there, yeah. I can hear you also.
Great. I find the example you gave about like the protocols versus a service very interesting. What do you think is a reasonable line to draw between like having a certain amount of contracts that are the underlying protocol part and then having other service type contracts on top of those that are upgradable?
That's a great question. And I would say not every use case across crypto requires or is necessarily improved by immutable smart contracts versus upgradable ones. But for infrastructure that is as high risk as cross-chain infrastructure, I feel strongly that it should be immutable. So if the infrastructure you're using could rug all of your end users. Like if there's risk of real funds and value, then immutability matters a lot, because your team should be able to audit the contracts and rest easy at night knowing that there couldn't be some override or change there. So from the cross-chain perspective, I think immutability is really, really critical. But I understand, for example, that when you're designing, let's say like 5-cent NFTs in a game, upgradability might give you the optionality to play around with, different constructs. So right now we're working with a game that is experimenting with ONFT and is really excited about it, but they want the optionality to be able to design for what their end users really want. And because it's 5-cent NFTs, the risk is a lot lower and they're pricing their security lower.
Awesome, thank you.
Thank you. Thanks for the nice talk. We have already implemented LayerZero in our next generation of our smart contract family. It is not published on mainnet yet because we all had the feeling that it adds another complexity, and especially when it comes to testing and when it comes to auditing. Can you share some experiences from the community, how they dealt with that? And if you, or can you even tell if you already heard of auditors that are capable of dealing with that complexity regarding LayerZero and all that?
That's a great question. And we pride ourselves at LayerZero on constantly trying to improve the developer experience. So always open to feedback on our docs, for example, and also showing smart contract examples to demonstrate how simple it actually is to integrate LayerZero. So for example, those OFT and ONFTs that I pointed to, those each took under a week to actually implement, and the base contracts have been audited 5 times and are public in our docs. But audits are something we think every team should do. In fact, we don't ever promote or co-market a project that is integrated with LayerZero until they've gone through a complimentary code review by the LayerZero Labs audit team and also have gone through one external security audit. We are very fortunate to have just closed our Series B recently, and we're the team across all of crypto that has spent the most on security audits. If there's ever a team that's integrating LayerZero and doesn't have the funds to commission an audit, we will pay that cost for applications. And it's something that I share very openly with projects that I work with. Some audit firms that we work closely with, we actually have 3 on retainer, are Zokyo. In fact, Hartej, the founder of Zokyo, is walking around here somewhere. OtterSec, Zelic, QuantStamp is certainly very familiar here. I know Halborn is spending more time in the cross-chain space as well. And there's some more that I'm excited to get to know, like the Nethermind team. But if you specifically are looking for referrals or are thinking through resource constraints, come talk to us, because there's nothing I enjoy more than helping a team get security audits. I think we're out of time here, but I really appreciate you all listening, and feel free to reach out on Twitter. You can DM us or on Telegram. Thanks so much.